Hi, folks. So we're going to go through the Chapter 3 assessment, and that way if you had questions about why you got something wrong or how to do something, and I didn't answer it in the comments on your test, you can totally just see it here. So I've grabbed all of the correct answers from a lot of different students. You can see different student work that got full credit for each question. There's only one that I showed, and not a lot of people did that one. So without any further ado, let's take a look. So this is option A. You've read them before. You have to graph sine and cosine. And let's take a look at some answers and explain why they got them. Cool. So credit out here to Caesar. Caesar did a great job with this one. So the reason that Caesar got full credit is that on each one of his graphs, there are horizontal axes. He chose to do them in radians. You could also do them in degrees. That's fine. There's also vertical axes on each one of them. He's also showing for sine that it starts at the midline, goes up to the max, down, and back up. It's doing all that in 2 pi. And Caesar is also definitely correctly showing for cosine it starts at the max, goes down to the min, goes back up to the max by 2 pi. So full credit, Caesar. Great job on that one. Suppose that you didn't want to do that. You chose option B. Well, this is what option B looked like. So awesome job to Denise, who got full credit for this one. Very well done. So it has the axes clearly labeled here. We can see here that midline is 4. Well, we can see this is our midline. It's in the middle of everything. We can see here that the amplitude is 3. That's because you go up from 4 to 7. That's right here for the max. You go down from 4 to 1. That's right here at the min. So Denise is clearly showing that. We can see that 5 is the phase displacement. So that's why it's starting right here, a maximum at 5. And we can see here at pi over 8, this is the slightly tricky part. If pi over 8 is our b value, you flip it. So now it's 8 over pi. And then you just want to get it to be over 2 pi, so you do, well, 16 over 2 pi. That's showing that from here to almost right about here, it's taking 16 units to do a full cycle. You could also graph this on Desmos and just see what you got. So great job, Denise. Awesome. So here, a lot of people were really close to this one. Let's see what an exact answer looks like. Okay, so good job, Benedict, for getting an exact answer. The reason Benedict got an exact answer is she clearly stated cotangent is cosine divided by sine in her answer. And then she also mentioned a second way, she didn't have to, but she did, that it's a reciprocal of tangent. She said because it has vertical asymptotes when tangent equals 0. And these asymptotes mark where cotangent is undefined. She also then went on to explain why sine helps us out here. She said this makes sense because since sine is 0 when tangent is 0. So she explained it a bunch of different ways. She also said if sine were equal to 0 in cotangent, the denominator would be 0 and the function would be undefined. So she explains it a good number of ways here. You only had to do one, but you did have to mention in your explanation sine and cosine, because this is based on the explanation between sine and cosine in the cotangent function. So you did have to explain why there is an asymptote happening where it is. Suppose you didn't do that one, you did the next one. Well, shout out to Crystal here. Good job, Crystal. You got full credit on this one. So she clearly states cosine is the reciprocal of secant, meaning that secant equals 1 over cosine. And she then says there are vertical asymptotes in secant because for values x equals 90 or x equals 270, cosine equals 0. So produce an undefined result that result in a vertical asymptote. Crystal, well explained, very clear, good job. Again, this one is saying based on the relationship of 1 and cosine in the secant function, Crystal clearly has all of that mentioned, and she's good to go. So let's take a look at this one. So you're given the graph, you had to make the equation. There were 2 points each. So shout out to Zaire, he gave this correct answer totally for the cosine function. So we can just hit each one of these individually, go through it. So cosine, we're going to see that we're starting at 6 is our midline. That's right here. It's right in the middle of the two. Sorry, I can't draw a straight line with this very easily. So you correctly saw that the amplitude is 4 because you go up 4 to get your maximum. That's here. You go down 4 to get your minimum. That's here. You then saw that because we're dealing with cosine, The phase displacement was 2.5. That's because cosine's at its maximum right there. And dealing with that, we saw that from here to here, Zaire correctly saw it was 25, so he did 2 pi divided by 25 for the b value. So good job, Zaire. This next one is the only one that I'm going to show simply because not a lot of people did it, but I'm going to use a lot of what Zaire put there because it's totally right. 6 is again our midline for the same reason it was before. We still have 4 as our amplitude, same reason as before. We still have, right over here, I should do that in red. We have pi over 13. That's because I had 2 pi over 26, and I just simplified down to there. That's perfectly fine. If you rounded and you were a bit off, that's fine. I accepted it, no problem. This was slightly difficult to read. My phase displacement came from here because we're dealing with a positive sign. That's happening at the midline, which is about here at 22.5. Either one of these, they share a lot of the same stuff, so shout out to Zaire. Good job with that. So let's take a look at this one, part 4. Part 4 was easily the most annoying part. A lot of people struggled with it, so I won't take a lot of time on this one. Shout out to Felix for this one. Good job, Felix. You explained it really well. So Felix saw that the period was 775 because from here to here, this was a distance of about 775. If you said 800, that's perfectly fine. I gave you credit for it. Felix then correctly showed how to get the horizontal dilation. He took the period from the previous one and divided by 2 pi. He simplified and got this. He then realized you had to do the old switcheroo for the b value here. Remember, you're putting it into a trig function, so it has to be flipped upside down. So Felix then saw the amplitude. He took the max minus the min. So it was the 225 minus the 50 divided by 2. That's where this 87.5 came in. If you said something like 90, I gave you credit. Felix, you were just very exact, so good on you. For the vertical translation, Felix took the max minus the amplitude we just saw. He got 137.5. So great, you can see that right about here. That's going right through the middle of all of these. Again, sorry, I can't draw a straight line. And then for the phase displacement, Felix saw that considering we're doing this with a positive cosine, that's starting where there's a max, so that's right about here. Cool. Awesome job, Felix. You did really well with 8. I'm also going to use your work for 9 because you did a great job on that too. So Felix said for 9, we were trying to say when it's 50 million miles away. He said 525 days, since it's where 50 million miles from Earth to Mars, which is lowest and closest to the point on the graph. And we can check that out here. This is when Mars is closest, which is about 525. So it's about 50 million miles away. Cool. And now these were the ones that a lot of people got a lot of half credit on, but not full. So I really want to take a look at that. Based on the equation of the graph, on what day will Earth and Mars first be closest to each other? Show or explain how you got it. Well, we already got that one from Felix, so we're good to go. Let's talk about 10 and 11. Now these were intervals. A bit of some vocab, folks. Intervals are spaces of time. So it's like, hey, you need a starting and an ending. We have that interval here too, so you need 2 numbers. Also, if we're talking numerically, you just have to plug in and see if you're right. Let's take a look. So shout out to Citycat. Good job with this one. Let's get rid of these. So 10. Citycat found these by, I'm assuming, Desmos. So she said the first 2 intervals are this. Technically, it's just the first interval, but she correctly gave the dates. This is when Earth is within 100 million miles of Mars, from 391.1 days to 666.32 days. Again, if you rounded and you said something like 400, I accepted that as a starting value, but you needed 2. Intervals are between 2 numbers. You can't just say one number of the interval. That'd be like me saying, hey, what time is it? Or what 2 meals are we between? And we're between lunch and dinner, and you just said lunch. Well, that doesn't make any sense. And Citycat correctly showed in 11 how to plug them in. So you just plug these in to the equation that you made in the first one. If you just showed the plugging in, I gave you full credit for it. So this would be a correct statement. I assume they just plugged into a calculator and hit enter and it said you were right. So good on you, Citycat. Well done. Option 5. Well, those previous ones were the ones that people kind of struggled with a little bit. This one people struggle with a lot. You had the option to avoid it, and a lot of people did. But let's take a look at this one and see how people did with it. So credit to Edwin. Really good job with this one, Edwin. You showed everything very well, very clear. I'm going to use the pen here just to make it easier to see. So we started out with our original equation. Edwin then subtracted the 140 on both sides. He then divided by the 90 on both sides. Now our trig function is by itself. So we got to deal with that trig function, and he does that correctly by using arc cosine. He kind of combined two steps here. That's perfectly all right. You are in pre-calc, you can combine two steps. First, he took arc cosine of both sides, and second, he flipped this fraction from both sides. Perfectly fine. Last but not least, we see that Edwin added the 150 on both sides, and you're good to go. And then he applied the definition of arc cosine, which means the leading fraction didn't change. We still have the, oh, good job adding in the plus minus, by the way. We still have the 380 over pi, and then it's cosine inverse of the negative blah, 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 times 2 pi n. Last but not least, you just distribute this fraction over the entire thing, and you get this. Technically, the pi shouldn't be there, but everything else is really good, but they could have just been left, so I gave credit. Good job, Edwin. All right, so this one, last one, looked a bit heavy, but a lot of people did a loophole. I'll explain in a second. So shout out to Anthony for getting this one. Good job, Anthony. So Anthony correctly saw that our midline is going to be 12 because that's what's happening at the equinoxes. He correctly saw that, wait a second, 12 plus or minus 3, so that's going to be our amplitude here. That's what's happening at the solstices. And then he found the 79 that was the midline here. So we're starting off with the midline on day 79 of the year at the spring equinox. And then he did our 360 divided by 2 pi. We got the 187. You might say, why 360? Well, 360 days in a year. Technically, the parentheses should be a bit different, but that's perfectly fine. I gave credit for it. Now, here's what a lot of people did, and I was wondering if people would do this. You just had to choose any 2 days and find the number of hours of daylight. Well, Anthony and a few other people just found the days I already gave you. That's perfectly fine. I gave you those days. You can totally use them. And that works. So, thank you all very much. I hope this helped. In case it didn't, see me in office hours. I will gladly answer all of your questions. So, you can do your best with this.